And welcome to our bonus features segment. We're looking at massive GPS errors happening here at the Smash News Network, least busted name in news. This is the total electron content forecast. It's the free electrons in between your GPS satellite and your GPS handset. Check out this anomaly happening. We see an anomaly happening here north of Hispaniola and east of Cuba. There's like an electron shortage happening in that area right there. You can see a little weird electron shortage happening there. Kind of strange, perhaps giving us insight into Earth's inner structures. But in any case, that's a total electron content forecast. It'll show you the most likely spots for GPS errors. Let's move on to this diagram, which is showing you distances to satellites in miles. Do we see any charging hazards? Not really. Just minor ones here over the Central Pacific. Here's the one-year chart of the electron flux. Those electrons are moving at high speeds, hence the greater than 2 million electron volts. Here is the 3-day GOES 16 and GOES 17 measurements using radiography to measure the free electrons at the F layer of the ionosphere, which we're also going to show you here. So here's the forecast. We saw quite a bit higher electron flux here than we expected, at least than NOAA expected. And I don't always forecast electrons, but when I do, I'm typically right. Because, well, it all has to do with the physics. Next, we're going to show you the F ionosphere layer here, located at about 300 kilometers of altitude. Here's your ionogram for the previous day. And we're certainly seeing some high-frequency anomalies happening in the southern hemisphere, no doubt about that. And also some wild swings to low-frequency anomalies. I can tell because I look at it daily. And thanks to our viewers who view the content daily, we're interested in things like a unified theory of physics. So it's part of the reason why we keep looking at the same stuff, because it gives us insight into otherwise unknown phenomenon. Remember, folks, if you can't explain your own theory, it's probably because you don't understand it. If you can't explain your own theory in simple terms, folks, it's probably nonsense. So we're seeing massive low-frequency anomalies happening here over the southern Pacific Ocean and Oceania, and then wild swings to high-frequency anomalies. Consistently anomalous regions here on the planet. Let that play through, and we'll show you the latest image on the ionogram and the anomalygram. So that's the anomaly in megahertz from the 30-day median. That's the ionogram for 1300 universal time. Anomalygram, ionogram. And let's continue on with additional bonus features. First, welcome to the Neo Renaissance. Congratulations on realizing the channel exists. Please support us via the links below the video, the links on our homepage, etc. Smashamash.com. There's a little bit of a teaser as to what our next chapter will include. Smashamash.com/SmashTeam is what we've replaced Patreon with. Something superior. It's our own subscription services site, thanks to the Smash Team members for increasing the probability these videos will continue to exist and remain publicly visible. If you don't follow us on Twitter, please do. Twitter.com/SmashAmash. We don't expect to get banned from Twitter. We will keep our mouths shut well enough to not get banned, as it's a pretty important platform. And here come additional bonus features in the form of the El Teide ground-based solar observatory. Here's what's going on from El Teide, Spain. And these sunspots have largely been stable over the past 24. No major flares. They've largely been underperforming. Let's take a look at the intensitygram and colorized magnetogram. We press refresh so you know that we're showing you the latest. Here's sunspot 2936 and its trailing spot group setting. It's still capable of producing large flares. Here is 2940. It's still capable of producing large flares. It's beta gamma class. And 2941 is my new favorite for producing major flares. We've got a huge disparity between these trailing South Pole umbrae and these leading North Pole umbrae. That's a serious ombre. And here are some more sunspots in the south. That region less likely to produce major flares. It's magnetically less complex, but it is still beta class. Here's 2941. We'll scroll over to 2940. Beta gamma class sunspot group there. And here's 2936. The last glimpse we'll get of it on the channel. We'll close out with the GO 16 and some close-ups in 304 and 171 angstroms actually. So there's 304 angstroms in the wide field view of the GO 16 SUVI. Some spectacular filaments down there in the northeast still hanging out. Yowzers. Here's the setting of Sunspot 2936. Spectacular it's getting as those groups are setting. Very nice, very nice. That's ultraviolet light. It's ionized iron. It's iron 9, I believe, is the ion shown here, the specific iron ionic species. Here's a zoomed out version of that. More wonderful imagery here from the SDO. I forgot to put it on loop. I apologize. It's well worth the wait. Massive filaments there associated with Sunspot 2936. Wait, there's more. Here's 2941, my favorite spot for a large flare at the moment. And these sunspots have all been underperforming in terms of their flare activity. We've seen quite a few large sunspots with complex fields not produce major flares. This is 2940. And we'll end the video on this full disk view. Thanks for tuning in, folks. Once again, congratulations on realizing that the channel exists. And may that solar wind be at your back.